In this video, we'll be graphing quadratic functions that contain an a and c value, and then be using various strategies to identify the x and y intercepts. So now as we calculate these, we'll actually need to find a couple of more key points. The first key point that you should already know is the y-intercept, and remember the y-intercept is the point on the graph where it crosses the y-axis. Remember the y-axis is your vertical axis, and it's the point where we cross the y-axis, which in this case is right here. So that is an actual point. So we have x is 0, y is -3. And remember, for all y-intercept points, x will always be 0, and we're finding the y value that corresponds with that point. In addition to the y-intercept point, we'll also need to find the x-intercept point. And the x-intercept point is the point on the graph where it crosses the x-axis. Remember, that's your horizontal axis. Now here, if we look, what we notice is if we look along this x-axis here, we actually notice that there are 2 points where we cross the x-axis. And as a result, we actually have 2 x-intercept points. We have the point x is 1, y is 0, and x is 3, y is 0. So sometimes you can have multiple intercept points. In this case, we have 2 points. The key part here for all of these x-intercept points is that y is equal to 0 because it lies directly on the x-intercept. So to start, let's look at an example that we've already completed in a previous video. So here we can see we have the function y equals -3x² plus 3 graphed. We can see our set of points that we were able to calculate here, and we can see this clearly on the graph. Now our axis of symmetry, we're going to still identify these other key pieces of information. Our axis of symmetry is still right there at x is equal to 0. It's a vertical line there. And then our vertex point we can see is right here at when x is 0, y is 3. So that's the first piece. Can we identify those other pieces of information? Now, for y-intercept and x-intercept, we can actually just calculate these by visually looking at the graph. Sometimes we can see them on the graph because they cross at really nice key points. So we know that the y-intercept occurs when we cross the y-axis, which is right here, and occurs when x is equal to 0. Those are 2 key points that we know about the y-intercept. So we can look in 2 places. One, we can look at the point where we cross on the y-axis, which is when x is 0, y is 3. We can also look here in our calculated table of values and see that when x is 0, y is 3. So we can see that in 2 different places here in our work. Then the second point that we need to calculate is the x-intercept. And the x-intercept occurs when we cross the x-axis. And we also know that this occurs when y is equal to 0. So we're looking for either where y is equal to 0 or the points where we cross the x-intercept, or the x-axis, which are right here. So here we have points of x is -1, y is 0, and we have the point x is 1, y is 0. So we actually have 2 points where we cross the x-axis, so we have 2 x-intercepts. And we can also confirm these looking in the table by looking for where y is equal to 0. We can see that occurring at these 2 points right here. Now in the second example here, you can again find points for these by calculating them by hand, putting your x values in here for x. Just to save us some time, I calculated these points for you because I simply wanted to show you a really special situation. So let's jump in and find those key points here, or those key values of this graph. So the first thing we need to find is our axis of symmetry, which we know is what cuts our parabola in half. So that here is still at the line x is equal to 0. Our vertex is occurring where our parabola changes direction, which is at x is 0, y is 2. Our y-intercept point is occurring when we cross the y-axis. So here is our y-axis. It's also occurring when x is equal to 0. We can see this point in 2 different places. So here our y-intercept point is when x is 0, y is 2. And then our x-intercept point is when the graph crosses the x-axis here. It's also when y is equal to 0. And what I notice when I look here is I notice that there's no points where y are equal to 0. They're all increasing forever and ever from 2 on up. And I notice that there's no crossing taking place at this x-intercept. That can happen. We can actually have situations that do not contain an x-intercept. And a part of that is because if we think about it, our domain here would be x is greater than or equal to 2. There's no point on that graph where x equals 0. And when this occurs, you can simply write there are no x-intercepts. That's going to happen in some cases depending on where the vertex of the parabola is as well as which direction it faces. So the last thing we're going to do here is we're going to calculate the x and y intercept without using a graph. So we're going to use our algebra skills to help us. So I'm going to have one section here be my y-intercept. And I'm going to start with, what do I know about my y-intercept point? Well, I know my y-intercept is a point, and it's the point where I cross the y-axis. And I know that every point on the y-axis has something special about it. I know that x is equal to 0. So essentially what I know here is that x is equal to 0, and I want to find the y value that corresponds with x when x is equal to 0 to make this particular equation true. So I'm going to take that original equation and I'm going to substitute x to be 0. And then I'm going to solve and find what on earth is y when x is 0. So here we have, 4 times 0 minus 36. So I get 0 minus 36. So y is equal to negative 36. So what I find here is that when x is 0, y is negative 36. So my y-intercept point is x is 0, y is negative 36. Then secondly here, if I wanted to calculate my x-intercepts by hand, again, I know that my x-intercept point is a point where y is 0. So I don't know x here, but I know that y is 0 because this point lies on the x-axis. So if I go and move forward to calculate some points here, we're going to substitute 0 in for y and find the x values that correspond with that. And so this starts to look like the square root strategy that I've learned for solving quadratics. So this uses my solving quadratics skills. So I'm going to get that x squared by itself, divide both sides by 4. So I end up with 9 is equal to x squared. So if I square root 9, I know that there are two numbers that when squared give me 9. So I know that there are two possible answers for x. X could be equal to 3, or x could be equal to negative 3. So I know here that I actually have two x-intercept points. One is where x is 3 and y is 0, and one is where x is negative 3 and y is 0. So now that I know how to solve quadratics, I actually have the skills to calculate x and y intercepts by hand if needed. Now let's apply that same thinking one last time. So I want to calculate my y-intercepts and my x-intercepts by hand. So remember our y-intercept points are found when x is equal to 0 and we don't know what y is. So we know that x is equal to 0 at this particular point. So I go to my equation and I substitute x is equal to 0. And I calculate the corresponding y value. So here I get 3 times 0 plus 12, 0 plus 12. So y is equal to 12. So I take that, put it back in. The point x is 0, y is 12 is my y-intercept point. Then I move forward and calculate my x-intercept points. So I know at this point y is always equal to 0. So I'm going to have the coordinate x is something, y is 0. So I now substitute 0 in for y and find the corresponding x. So subtract 12, divide by 3. So I have negative 4 is equal to x squared. And then I notice that if I try to square root that negative 4, I get an error because I know that I cannot have a negative number under the square root because nothing squared gives me negative 4. So what this is telling me is there are no x-intercepts for this particular graph. So this graph will never actually cross the x-axis. It will either go up and never cross or down and never cross. That's what we expect to see if we graph this on a coordinate plane.